a previously long-dormant volcano in Ethiopia's Afar region, identified in reports as highly gubby, exploded suddenly, producing a dramatic ash column and local ashfall. Several outlets and local authorities describe this as the first known Holocene, modern era, eruption of that specific vent in roughly 10,000 to 12,000 years, which is why scientists and meteorological centers treated the event as unusual and newsworthy. The eruption produced a very high ash plume. Satellite and advisory centers reported altitudes around 12 to 14 kilometers, approximately 40 to 45,000 feet, and ash and volcanic gases were carried eastward across the Red Sea and Arabian Peninsula, reaching airspaces used by long-haul flights. Because modern jet airliners cruise at the same heights as the ash cloud, airlines in the region and in India temporarily cancelled or rerouted flights, and aviation advisories were issued. That immediate aviation risk, engine damage, visibility, instrument problems, was one of the first real-world impacts. Satellite instruments, for example, Copernicus Sentinel-5P and other sensors, tracked a large sulfur dioxide, SO2, plume traveling thousands of kilometers from the eruption, demonstrating how volcanic gas emissions can travel far beyond the eruption site. SO2 can oxidize into sulfate aerosols and form VOG, volcanic smog, or acid rain. It also has short-term respiratory impacts and can degrade air quality hundreds to thousands of kilometers downwind, depending on winds and altitude. Geologically, this eruption must be read in the context of the Afar Triple Junction, the place where the Red Sea, Gulf of Aden, and East African rift systems meet and continental crust is actively stretching and breaking apart. Afar is one of the world's best modern examples of early continental rifting. Magma intrusions, fissure eruptions, and localized surface uplift or subsidence are expected as plates diverge. That tectonic setting explains why eruptions there are often fissure type, and why even long quiet vents can become active when pressure builds. Hazards from this single event are several and act at different spatial scales. 1. Immediate local ashfall. Villages near the vent were reported covered in ash. Ash can collapse roofs, contaminate water, destroy grazing pastures and crops, and cause direct respiratory problems for people and livestock. 2. Aviation hazard. Ash and abrasive particles in cruise altitudes can cause severe engine damage and are a reason for flight cancellations and reroutes. 3. Long-range gaseous and aerosol effects. Large SO2 plumes can create regional air quality issues, VOG, and modify sunlight and short-term weather locally. Satellites already map the plume across the Arabian Peninsula. 4. Ground deformation and seismicity. Preceding or following eruptions, GPS/INSAR often detect several centimeters of uplift or subsidence and swarms of small to moderate earthquakes. These signal continuing magma movement underground and raise the chance of repeated eruptions or new fissures near inhabited areas. For people and communities in Afar, the most pressing practical consequences are damage to grazing and water sources. Ash smothers pasture, animals get sick. Disruption of local transport and tourism, and immediate health risks to vulnerable people from ash and gas inhalation. Emergency responses typically include providing clean water, advising people to stay indoors when ashfall is heavy, distributing masks for particulate protection, and checking livestock and water supplies. Internationally, the main short-term impacts are aviation safety precautions and temporary air quality alerts in downwind countries. Scientifically, the eruption is a reminder that dormant is not the same as extinct. In rift systems like Afar, magma pathways and shallow intrusions can reactivate vents after millennia. Monitoring, satellites, seismic networks, gas sensing, and local observations matters because satellites can quickly map ash and gas plumes, while local seismic, just GPS networks reveal whether magma is still rising, information that shapes warnings for aviation and nearby communities. Recent research and long-term monitoring of afar show that the region regularly experiences magma intrusions that open new fissures and slowly evolve into wider rift structures over tens of thousands of years. What could come next? Short term, there can be repeat activity, new ash pulses, further ashfall, or short fissure eruptions, while the magma system is still adjusting. Authorities and volcanological observatories watch for fresh seismic swarms, rising gas emissions, or renewed ground uplift. Medium to long term, the Afar region will continue to be tectonically and volcanically active over geological timescales, a stretch that will produce more intrusions, fissures, and volcanic centers as the continent slowly rifts. That is not a sudden continent split scenario for human lifetimes, but it is a real measurable process that